Hello. The sun just delivered something we haven't seen all year. And honestly, two more are already on their way here. We're talking about an X5, 1-class solar flare that erupted this morning at 5 a.m. Eastern Time from active region 4274. This is the sixth largest flare of the entire solar cycle 25. Think about that for a second. We've been tracking this solar cycle for years now, and this morning's explosion ranks in the top 6. That's significant. But here's where it gets interesting. This flare launched a massive coronal mass ejection directly toward Earth. The initial velocity estimate? About 1,850 kilometers per second. That's roughly 4.4 million miles per hour screaming through space in our direction. Let me walk you through the math, because it's actually pretty straightforward. Earth sits about 150 million kilometers from the Sun. At 1,850 kilometers per second, you're looking at approximately 22 hours transit time. So, we're expecting impact around midday tomorrow, November 12th. Though I have to tell you, there's about a 7-hour margin of error on that window. Could hit earlier in the morning, could arrive in the evening. We won't know precisely until it gets closer. Now, if this were just one solar storm, that would be noteworthy enough. But this situation is something else entirely. There are already 2 coronal mass ejections ahead of this one. Both came from the exact same active region. Both are headed straight for us. 2 days ago on November 9th, region 4274 produced an X17 class flare. That erupted at 2:35 inches the morning Eastern Time. Less than 24 hours later, the same region fired off an X1 flare around 4:30 a.m. Both of those launched Earth-directed CMEs. Here's what makes this critical. The first CME was the slowest. The second was faster. This newest one, from the X5, S1, it's the fastest of all 3. When a faster CME catches up to a slower one, they don't just pass by each other. They collide. They compress. The technical term is pancaking, and what it does is amplify the combined shock. The magnetic fields interact, and you end up with something significantly more powerful than either storm would have been on its own. So we're looking at a triple collision scenario here. The first CME should be arriving within hours tonight. Then the second one hits, creating a bigger shock. And then this third one, traveling at the highest velocity, delivers what I think is going to be the most intense punch. I'm going to be very direct about the probabilities here because I think people deserve to know what we're actually facing. A G3 strong geomagnetic storm? I think that's essentially guaranteed. I'd put that at nearly 100% certainty. G4 severe conditions? I'm estimating about an 80% probability we reach that level. G5 extreme storm? This is where it gets really interesting. I'd say we're looking at somewhere between 50 and 60% chance of hitting G5. Maybe even a bit higher, depending on how these CMEs interact when they arrive. NOAA Space Weather Prediction Center clearly agrees this is serious because they've been escalating their watches all day. Tonight, November 11th, they've issued a G2 moderate storm watch. Tomorrow, November 12th, they upgraded that to G4 severe. And they're maintaining a G3 watch for November 13th as well. That X5, one flare this morning, didn't just launch the CME. It also triggered immediate effects. We saw strong R3 level radio blackouts across Africa and Europe. Anyone trying to use high-frequency communications on the sunlit side of Earth experienced significant disruptions for hours. That's what X-class flares do. The extreme ultraviolet radiation hits the upper atmosphere almost instantly and ionizes it. But those radio blackouts are temporary. They clear up. The geomagnetic storms? That's where the real sustained impact happens. Let me tell you something about region 4274, because this sunspot group has been absolutely relentless. In the last 7 days, it has produced 5 X-class solar flares. 5. That kind of sustained major activity from a single region is not common. And here's what concerns me. It's still maintaining a very strong, complex magnetic structure. The scientists monitoring this region are saying it has potential for more eruptions. Thank you for being with us. Please subscribe, share, and like. So how do we know all this? How are we tracking these CMEs with such precision? Multiple spacecraft are giving us the data. The Solar and Heliospheric Observatory, SOHO, captured the initial coronagraph images, showing these CMEs blasting out of the solar corona. NASA's Solar Dynamics Observatory recorded the flares themselves in multiple wavelengths, showing us the magnetic reconnection events that triggered everything. Now, there's an aurora photographer named Vincent Ledvina who's been doing some excellent analysis on this. He's published detailed trajectory models for all 3 CMEs. According to his calculations, the first one, from the X1 7 flare, should impact around 4 universal time tomorrow. The second, from the X1 2, follows at approximately 15 universal time. And this newest one could arrive as early as 9 a.m., though again, significant uncertainty there. What Ledvina is saying, and I agree with this, is don't get too fixated on exact times. The impact window basically starts now and runs through the next 48 to 72 hours. If you're hoping to see auroras, be ready both tonight and tomorrow night. There's a solar physicist, Dr. Ryan French, who actually observed auroras from an airplane while flying to Chicago during the last geomagnetic storm. That was just last night. He's confirming we had strong storm conditions then, and he's expecting similar or more intense conditions again tonight and tomorrow. The Space Weather Prediction Center is being very honest about the complexity here. They're saying the most recent CME has its main ejecta aimed slightly north and ahead of Earth's orbit. Plus, the 2 previous CMEs are already in the mix, expected to arrive first. That makes modeling this incredibly challenging. But here's what they're confident about. They believe there's definitely an Earth component to this latest CME. High confidence on that? The timing? Moderate confidence. And they're very clear that the real intensity won't be known until these storms reach the L1 point. L1 is critical. It's a point in space about 1 million miles upstream from Earth, where we have satellites continuously monitoring the solar wind. Those satellites will measure the speed, the density, and most importantly, the magnetic field orientation of these incoming CMEs. That magnetic field orientation is everything. If the CME carries a southward pointing field, it connects efficiently with Earth's northward field. That opens the door for massive energy transfer. Charged particles funnel down toward the poles, and you get spectacular auroras. If it's oriented northward, the fields repel. The storm mostly deflects around us with minimal effects. We won't know that magnetic field orientation until the CMEs actually reach L1. That's the final variable. We can model the velocity pretty well. We can estimate the mass. We can predict timing within a reasonable window. But that magnetic field? It rotates and fluctuates during the entire journey from Sun to Earth. Only direct measurement tells us what we're actually dealing with. If all 3 of these CMEs arrive with favorable southward components, and if this pancaking compression plays out the way I think it will, we could be looking at something comparable to what we saw in May 2024. That storm hit G5 extreme levels. Auroras were visible all the way down to the Mexico border. This setup has similar potential. 3 Earth-directed CMEs. The high velocity of this third one. The sustained activity from region 4274. Everything is pointing toward a major space weather event. For people in northern latitudes, This could be exceptional aurora viewing. Mid-latitude locations, including the northern United States, should absolutely be monitoring forecasts closely. If we hit G5, auroras could extend well into the southern states like they did earlier this year. I want to be clear, this forecast is still evolving. Space Weather Prediction Center will keep updating as new data comes in from L1. Real-time measurements will sharpen the arrival times and intensity predictions. But the core scenario here is solid. 3 major solar storms inbound, sequential arrivals, combined impact potential that could produce the strongest geomagnetic disturbance we've seen all year. There are practical impacts to consider. High-frequency radio could face disruptions. GPS accuracy might degrade. Satellite operations are at elevated risk during severe storms. Power grid operators in northern regions have already been notified about possible induced currents that can stress transformers. But for those of you who just want to see one of nature's most incredible light shows, the next 48 hours offer a real opportunity here. You need clear skies and a view toward the north. Aurora Alert apps will give you real-time updates as conditions develop. The sun has delivered something extraordinary. Region 4274 is still rotating across the solar disk, still visible, still magnetically complex. More flares remain possible. But right now, our attention is on these 3 storms already in transit. Less than 24 hours until the first impacts begin. I think we're in for something significant here. Thank you for being with us. Please subscribe, share, and like.